Welcome to a lesson with Dr. Powell. Let's jump right into some complex numbers. So we might ask ourselves a question. If I have a function of a complex variable, usually denoted with a z, where a complex number is something like a plus bi with the real part and the imaginary part, is there a way to take derivatives? Is there a way of taking an antiderivative or integrating somehow like this? What is this type of idea even possible? So, and what would it mean? Well, let's jump into what complex numbers are first of all, how to visualize them. If we take this as the x-axis as the real axis and y as the imaginary axis, then if I have a number like 1 plus I would plot it here, where I'm just thinking component-wise, where this would be like an x-coordinate, that would be, and the coefficient of I is like the y-coordinate. Or if I went up to something like this, maybe this could be like 2 plus 3i. 3 represents the height and 2 represents the distance over here. Okay, so that's what a complex number is. Now, what does it mean to integrate? If I have something like f of z, and then maybe a dz here, and how would I be doing this? Now, since complex numbers live in a plane, when we integrate, we need to integrate along something. So actually, we're doing line integrals. So maybe we have some kind of curve or path, C, that we have to deal with. All right, that's maybe one notion. Another thing we realize is that what is z in terms of x and y? I'm going to think of it z literally as being x plus I, y. So that dz will be considered as a complex number, but in little differentials, dx plus I dy. Now, we're going to split f of z up as follows. We're going to think of f of z as being equal to u plus iv, where u is simply just the real part of the function and v is the imaginary part of the function. I didn't use a function notation here, but we'll just remember that these guys are functions here and depend on z, which is x plus iy. Okay, so really this integral will look something like this. U plus IV, at least in this part right here, the differential part, this is multiplied by, in usual complex arithmetic multiplication, dx plus I dy. Now, if we do this, let's just, we can kind of work through this thinking of foiling this out. Let's think about everything that, let's see, everything that will go with dx is simply u plus iv dx. Everything that goes with dy, we're multiplying an I to it. And so that would become a ui and then a minus. Let's kind of get real part and imaginary parts here straight. So I times I is minus 1, so you get a minus v, and then I times u, so plus iu dy. Okay, so we're really looking at, this is a line integral, and we have to keep in mind, there's the real part of the line integral will be considered by just looking at the u and the negative v part. So you kind of have two line integrals happening here. You have the real part of this, so it's u dx minus v dy. You also have the part which is right here, which is you can factor out the I, and then you have v, let's see, v dx, and then you have a plus u dy. Okay, so we have this this going on right here. and we're adding these together. So we can really think about this right here as being a line integral. Let's look at an example of this type of thing, and we'll do that in the next video. Thanks for watching.